Okay, so today we're going to do 3B3 notes. We're going to talk more about proofs, so we're going to introduce a few more if-then statements today. Make sure you have your pink sheets out. We're going to talk about right angles, congruence theorem. So we know that all right angles are congruent. Okay, so we're going to use that today in our proofs. Remember, a theorem is a statement that can be proven. Okay, so we are going to do this first proof. Given that angle 1 and angle 2 are right angles, we're trying to prove that angle 1 and angle 2 are congruent. So the first thing we're going to say is that we know that angle 1 and angle 2 are right angles, because that's given. Okay, now we're trying to prove this theorem. So when we prove the theorem, we can't just go right into the fact that we know that right angles are congruent. So we're going to kind of work around that. So if they're right angles, don't we know that they're 90 degrees? So we can say the measure of angle 1 equals 90 degrees, and the measure of angle 2 equals 90 degrees. Okay? Now if you think about the reason, we know that all right angles are 90 degrees. So if right angles, then angles measure is equal to 90 degrees. This is coming right from your pink sheet. Okay, well, we learned that if two angles were equal to the same thing, then they have to be equal to each other. So we can say now that the measure of angle 1 equals the measure of angle 2. And that's because of substitution. Right, so substitution property of equality. Once we know they're equal, then we have to know they're congruent. So that is my goal, is to get to the fact that they're congruent. And I've done that. So angle 1 is congruent to angle 2. And that's because if angles are equal in measure, then angles have to be congruent. Okay, remember you can use a congruent symbol here. Okay, so that one was pretty easy. Let's talk about two more theorems. We're going to talk about the congruent supplements theorem. It says this: if two angles are supplementary to the same angle, then the angles are congruent. And again, this is on your pink sheet if you go down to 3B, unit 3B now. So if we know that angle 1 and angle 2 are supplementary, remember, to be supplementary, you add up to 180 degrees. And angle 2 and angle 3 are supplementary. Then we know that angle 1 has to be congruent to angle 3 in order for that statement to be true. Okay? Now the complement theorem says the same thing, except it talks about complementary angles. So if two angles are complementary, to the same angle, then the angles are congruent. Okay, so if we know that, again, like angle 1 and angle 2 are complementary, and angle 2 and angle 3 are complementary, then we know that angle 1 has to be congruent to angle 3. If you think about that, if you just fill in numbers here, let's say, 20 degrees is angle 1, and angle 2 is 70 degrees, then the only way for this to work is that angle 2 is still 70 degrees, so angle 3 has to be 20 degrees in order to add up to 90. So it makes sense if you think about an example. Okay, so now we're going to do a couple proofs with this idea. Right, we're going to prove the case of the congruent supplements theorem. So we're going to prove that when two angles are supplementary to the same angle, they have to be congruent. Okay, so we're told that angle A and angle B are supplements, and angle C and angle B are supplements, and we're going to try to prove that angle A is congruent to angle C. So the first thing I'm going to do is I'm going to think about what it means to be supplementary. Now we talked about the fact that being supplementary means that you have to add up to 180 degrees. So that means that the measure of angle A plus the measure of angle B has to equal 180 degrees. And the measure of angle C plus the measure of angle B has to equal 180 degrees. Right? Because really that's just the definition of being supplementary. So if two angles are supplementary, then the angle sum equals 180 degrees. Okay, well, if you go back to the proof before this, the next thing we would do, which we've done in almost every proof we've encountered now, is substitution, right? If they're both equal to 180 degrees, then they have to be equal to each other. So I can take the measure of angle A plus the measure of angle B and set it equal to the measure of angle C plus the measure of angle B. Whoops, I numbered this wrong. This should be step 2. Okay, so then this is just substitution. Property of equality. Okay, and now hopefully you see what we're going to do next. We have the measure of angle B in common on both sides. So I'm now going to subtract that, giving me the measure of angle A equals the measure of angle C, and that's because of subtraction. Okay, always go back. What are we trying to prove? We're trying to prove these angles are congruent. Well, if they're equal, then they have to be congruent. So angle A is congruent to angle C. We've gotten to the end. We just need our reason. And finally, if angles are equal in measure, then angles are congruent. All right. Let's take a look at the next one. Example 3. They're giving us that the information that the measure of angle 2 is 2 times the size of the measure of angle 1. We're trying to prove that the measure of angle 1 equals 60 degrees. Okay, so here's a couple of things I'm thinking right now. Right now I'm thinking, okay, these are adjacent angles and they're forming a straight line. So I know that these angles have to be supplementary. And because I'm trying to prove that there's an angle measure of 60 degrees, I'm going to have to introduce some numbers into this, right? I'm going to have to introduce some measurements of these angles. Well, the only measurement I know right now is the fact that there's 180 degrees in this line, and this angle is twice the other one. So I know I have to get to an equation. So that's where I'm going to kind of try to get to. Okay, so this is the given information, so we know we list that first. Alright, and so step 1 is just given. Okay, so now what I'm going to do is I'm going to use the fact that I know that these are a straight angle and therefore measuring 180 degrees. So step 2, we can say the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And we know that if you have a straight angle, then the measure equals 180 degrees. Okay? Well, think about this. Somehow, I have to get just the measure of angle 1 by itself. It's kind of like I have like x plus y equals 180, and I want to eliminate y being the measure of angle 2. Well, if I go back up to my previous given information, I know that the measure of angle 2 is actually equal to 2 times the measure of angle 1, which will help me to eliminate this variable. So that's what I'm going to do. I'm going to substitute. So I get the measure of angle 1 plus 2 times the measure of angle 1 equals 180 degrees. Okay, and that's just substitution. Property of equality. Okay, remember we can use POE. Okay, well now it's like I have x plus 2x. So they're like terms. I can combine them now. So the one measure of angle 1 plus 2 measures of angle 1 is going to give me 3 times the measure of angle 1. And that's going to be equal to 180 degrees. And we can just call that combining like terms. So hopefully you see where we're going to end, right? We're trying to get to the fact that the measure of angle 1 equals 60 degrees. So if you think about this like 3x equals 180 degrees, then you got to divide by 3 on both sides. And when you do that, we get the measure of angle 1 equals 60 degrees. So that would give us the division, POE, or property of equality. Okay, let's keep going. Okay, so now in our picture, we have, what I'm noticing is we have some vertical angles, okay? We have an angle that's kind of off here to itself, but here what I see given is that angle 2 and angle 1 are congruent. So I'm going to make sure I mark that in my picture. So in my mind, I'm thinking, okay, well, if these are vertical angles, what do I know about vertical angles, right? Don't they have to be congruent? Well, I should be able to get to the fact that these two angles are congruent then. Okay, so I have to introduce the fact that I know these angles are vertical and therefore they're congruent. So that's what I'm going to do first. So I know that angle 2 is congruent to angle 3 because vertical angles are congruent. And we can say if vertical angles, then angles are congruent. Okay. Well, look what we have here. It's like that chain, right? Angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. That is that match up there, so those cancel, right? And we can say now that angle 1 is congruent to angle 3. And hopefully you remember the name of the property. It's the transitive property of congruence. POC, right? We're talking about congruence, we have to use the C there. When you talk about equality, you use the equals. Okay, so that was a nice, short, easy proof. All right, let's look at this next one. Okay, now I want you to see how this one's set up, example 5 here. So here I have, I can see here I have a linear pair. They're going to be 180 degrees, right? Angle 4 is, farther down that line. It's not adjacent to these angles. So I'm just kind of evaluating my picture. It's telling me that angle 1 and angle 2 are supplements, and angle 1 and angle 4 are supplements, and that the measure of angle 2 equals 45 degrees. I'm going to put that in my picture here, because that's going to help me to get to where I need to go. It tells me they want me to prove that the measure of angle 4 equals 45 degrees. Now I want you to notice the given information. There's 3 pieces of given information here in this problem, but we're only starting out with 2 of them. You don't always have to put all of the given information at the beginning, okay? Sometimes it makes more sense flow-wise to put it at the end or, somewhere in the middle. So we're going to save it for a little while, and then we're going to use it in a little bit, okay? So we know this is given. Now we just learned the theorem and we proved it. So we know that if 2 angles are supplementary to the same angle, which angle 1 and angle 2 are supplementary, angle 1 and angle 4 are supplementary, therefore 2 and 4 have to be the same. They have to be congruent. So we can say that angle 2 is congruent to angle 4. And now our reason, and you'll see it on your sheet, it's our if-then statement. If 2 angles are supplementary to the same angle, then the angles are congruent. Okay? So that's that theorem we just talked about at the beginning here. So now, think about what we have to do. We're not trying to prove congruence, we're trying to prove equality. So what I'm going to do next is I'm going to move into some equals, okay? Because I want to say now that the measure of angle 2 equals the measure of angle 4. And you should know the reason for this now, right? If 2 angles are congruent, then the angles are equal in measure. Okay, step 4. Okay, somehow I have to be able to say that the measure of angle 4 equals 45 degrees. Well, if you go back up to the given, now is the time to introduce that. Okay, so now it makes more sense to say that. So now I'm going to say the measure of angle 2 equals 45 degrees. And the reason is it's given. So notice I'm just breaking up my given information here. Okay, so now I'm stating that it's given. Now I'm ready to do some substitution, right? I know now that the measure of angle 2 is 45 degrees, so I can replace measure of angle 2 with that 45 degrees. So this is just substitution. I'm almost there. I need to make it look just like they want it to look, which is where the measure of angle 4 is on the left side. So remember that trick in order to flip it. We're talking about equality, so we have to use POE, right? So we're going to say the measure of angle 4 is equal to 45 degrees, and that's because of the symmetric property of equality. So you always want to ask yourself, am I trying to get to, if I'm trying to prove something that's equal, then I really need an equation in some point, or I need to talk about those property of equalities. If you're trying to prove congruence, you want to make sure you're using POC, and you're talking about congruence, and you don't have the little measure symbol there. So it's those little things that you want to pay attention to. Okay, we're going to shift gears a little bit, and we're going to solve an equation now. So given this picture, we're looking for some angle measures, okay? So what I'm going to do is I'm going to just start right into this. So I can see here that we have this right angle, okay? So I know that those two angles are complementary. So I know that 2x minus 3 plus 38 has to equal 90 degrees, right? So I'm just going to start solving, okay? I'm going to combine my like terms, get 35. I'm going to then subtract 35 on both sides, giving me 55, dividing by 2, and I get x is 27.5. Now, it wanted you to solve, but then we have to find all these angles. So I know that x is 27.5, so remember, we can just substitute in. Now, in terms of angle NOP, I can substitute the 27.5, multiply by 2, and subtract 3, or and that would be a good way to verify my work. Or I could just do 90 minus 38, right? Because I know that those two angles are complementary. So angle NOP is, what, 52 degrees? Okay, I'm just going to fill that in my picture. Okay, I'm going to go around now. So I know that this is 90 degrees, and this is 90 degrees, and these two have to add up to 90 degrees. Alright, I also know that I have vertical angles here. So if you take a look here at this x, we can see that this 38 degrees also is going to be down here. So this has to be 38 degrees. And then you should be able to see these vertical angles here, where if this is 52 degrees, then this angle has to be 52 degrees. Okay, so now all I have to do is kind of substitute everything in here. So the measure of angle ROQ is 38 degrees. Angle QOP has to be the 90 degrees because we know that two lines intersect when they form a 90-degree angle. All four of those have to be 90-degree angles. And then finally, angle SOR has to be that other vertical angle of 52 degrees. Okay? And that's it.